Welcome to AP Environmental Science. In this video, we are going to talk a little bit about the distribution of natural energy resources, particularly the non-renewable resources and where they're found throughout the globe. Now, the non-renewable resources that we are focusing on in this video include uranium, coal, crude oil, and natural gas. And also refresh your memory on the difference between the term resource and reserve. Resource is all of that particular item that exists on the planet, whereas reserve is how much of that is actually economically feasible to extract from the earth. And also keep in mind, just because a resource is found somewhere does not mean that we're actively extracting that resource. I included on this slide a picture of the globe that shows the bedrock geology over time. You're going to notice that these non-renewable resources are not evenly distributed throughout the world. In fact, their distribution has to do with the geologic history of that location. Also, keep in mind that where some of these resources are found really help to dictate the direction that that nation went when pursuing their energy needs. And we'll talk more about that in subsequent videos. We'll start here with uranium, and by far the largest reserve of uranium is in Australia, and you can see that other countries with large reserves of uranium are in those darker purple shades on this map. If we look at crude oil, by far the largest reserve would be in the Middle East and in Canada and Venezuela. Venezuela is that country in northern South America that is very darkly shaded in. Then you can see the largest reserves of natural gas are particularly in the Middle East, Russia, and the United States. Again, we're seeing some trends that are showing similarities here between the natural gas and the crude oil, and we'll talk more about that in a little bit. And then finally, coal has the largest reserves in the United States, Russia, and China. I put in this second map here to zoom in on the United States to see a little more detail on where in the United States this coal is actually found. And in fact, there's different levels or different types of coal, and depending on the geologic history of a particular location, it has a different level of coal. And that impacts the amount of air pollution that's released when that particular type of coal is burned for powering a coal-fired power plant. So here's the geologic processes to make coal. Now, coal starts out as peat, and peat is not actually coal. Peat is this vegetation debris that's kind of buried under some kind of anaerobic conditions, meaning there's no oxygen, and it's partially decomposed. Now, some people actually mine peat to use to burn to heat homes, but for the purpose of this particular process, we're going to say that peat doesn't get mined, it just kind of stays there, and then it gets compact and compressed between sediment layers. And over a long period of time, that becomes lignite, which is our kind of our brown coal. Then eventually that lignite, over more time and more pressure, becomes sub-bituminous coal or bituminous coal. And then eventually it can move all the way to the end and become anthracite. Now, anthracite is kind of the most desirable coal. It's going to have less sulfur emissions compared to the lignite, but in general, coal has a whole lot of emissions. You will need to know the order of the coal. You have lignite, then subbituminous, then bituminous, and then anthracite. With anthracite being the most desirable, it has that high energy content compared to the lignite, which is the least desirable. If we look at the way that petroleum and natural gas are formed, it's a similar process to coal. However, our starting material and the conditions are just a little bit different. So typically, oil and natural gas formations are formed by plant and animal remains formed kind of at the bottom of the ocean, compressed underneath the sand and silty sediment. Now, over time, they get compressed, and that leads to these changes in that carbon structure. If you look at, again, a map of the United States, you can see that the oil and natural gas formations tend to be found in about the same location. And that, again, has to do with the way that they are formed. So on this map, the green and the red, the green represents the oil, whereas the red represents the natural gas. So you can see that they're found in about the same locations. And I put this image here on the bottom of the screen to help you just visualize what's happening underground. So oil would be found in this reservoir. It's kind of this pocket in the rock where the liquid accumulates. But of course that gas, the natural gas, is methane. It's a little lighter than the oil. So that methane is going to be found kind of at the top of that little pocket. Now, natural gas can also be found in shale rock, and we'll talk more about that in our fossil fuels video. So in summary, what you really need to take away from this is that the non-renewable resources are not evenly distributed across the globe. They are found in certain locations based off of those geologic formations and the geologic history, so the time and pressure that were exhibited on that particular location. Now again, please send me your questions here at the end, and I hope that as you watch this video, you were able to learn something.